Hello everyone, welcome to Solely Science. This video is based on the experiment Nodal slide. We will quickly see how we can perform this experiment. First of all, aim of the experiment, it is to determine the focal length of combination of convex lenses. So we will have two lenses in this experiment. Let's name this as lens 1 and lens 2, and then we need to first find the focal length of the individual lens and then the combination of these two lenses. Apparatus required include two convex lenses, optical bench, lamp, mirror, cross-slit, screen, nodal slide assembly, etc. Formula used for this experiment is 1 upon f equals to 1 upon f1 plus 1 upon f2 minus d upon f1 into f2. In some books we also get x in place of d. Both of them means the distance between the two lenses. F1 and F2 are the focal length of the two lenses, and capital F is the focal length of the combination of two lenses. So now we will see the diagrammatic representation. This is how the setup is represented when we have only one lens in the system, whereas when we have two lenses, then this is how the setup is represented. So basically it works like this. We have four main apparatuses here. The first one is the lamp, which is acting as the light source. Then we have cross-slit screen. Then we will have lens and the mirror, and these are mounted on the optical bench. Alright, the light from the lamp will first hit the screen, cross-slit screen, and here we will have a opening which will be in the shape of like this. So the light will travel through this opening and then it will hit the lens. After passing through the lens, the light will then go to the mirror. So this is the path that is traveled by the light, initial path. Then after hitting the mirror, the light will be reflected back. So it will be reflected back again and then it will converge here. So on the cross-slit screen you will get the image. First we will have the assembly like this, then you will need to place this lens and adjust the distance so that you will have the image at whatever position you will get a sharp image. Stop there and then note down the distance value. Here is f1 or f2. This will give you the value of the focal length, and two lenses will be combined. So here we will have the lamp, the cross-slit screen, the lens 1, lens 2 and the mirror. The light will travel along the same path. It will hit the lens and then go towards the mirror. From the mirror the light will be reflected back and it will form an image on the cross-slit screen. So this is how the working of the experiment is. Now we will quickly see the procedure of the experiment. First step, mount the light source, cross-slit screen, nodal slide, mirror on the optical bench such that the axes lie on the same horizontal line. Next, put only one lens and adjust the position until a sharp image is obtained and note down the reading, like I already explained you in the diagram. But then after getting the reading, you will have to rotate this lens. Like suppose first you kept the lens like this, and this give you the reading for the first phase. In the next step you need to rotate it like this and you will have the reading for this other phase. So in this way you will complete the reading for one lens. Similarly you need to follow the step for the other lens also. By this you will have the value of focal length, that is f1 and f2. Then we are on this step. Similarly do it for the second lens and you will have the value of focal length, that is f2. Now we will bring both lenses together and place them on the lens carriage. Adjust the distance so that they are at equal distance from the center point. So now we will see the combined system. We have brought both the lenses together and placed them on the nodal slide assembly, and here is the center point, so we have placed them at equal distance. And then similarly from at whatever position the image will be obtained, the readings will be noted down. So determine the focal length of first side of the lens, and then by rotating the nodal slide assembly by 180 degrees. So similarly we will first note down the readings by keeping the lens like this, and then in the next step we will rotate it and then note down the readings. After that we need to make changes in the distance value, like we need to change distance in the steps, so like 4 centimeters, 6 centimeter and 8 centimeter, and then note down the readings. So coming to the observation table, this is the observation table for the first part of the experiment, wherein we had first lens, we incident light on the one face and then on the other face, and then measured the values and we got the focal length f1. Similarly we did for the lens 2. Light was incident on one face, then on the other face the positions were noted down and focal length was calculated. This was for the first part of the experiment. And here is the table for the second part of the experiment. Light incident on one face, other face, but here we even started changing the distance, so there is an additional column here. We first kept the distance as 4 centimeter, then 6 centimeter, then 8 centimeter, and noted down the required values, and then we had the mean focal length, that is capital F. So in this way the experiment is completed. You will write down the result as the focal length was successfully determined, and the precautions that one need to take while performing this experiments are: take readings only when sharp and well defined image is obtained. Don't take reading when you will have a blur image, since it will raise an error. And then next thing is, lens carriage should not be loose, everything should be tightly mounted. And at last, take good number of readings to eliminate errors and increase accuracy. So that's it for the nodal slide experiment. Thank you so much for watching till the end, and do subscribe to Solely Science.